Hi, welcome back to the XII Sound channel and part 34 in the series all about my Project 12 DIY modular analog synth. And this time round I've finally got round to building a sample and hold module. Now the design I've chosen is the one by Moritz Klein. One of the two main reasons for that: one is it's a really simple design and the circuit is fairly straightforward, and I'm all about keeping things simple and therefore more accessible so other people can enjoy this hobby. The other thing is I found his video, which is absolutely brilliant. Real in-depth description of how each component works and how it works within the circuit and how the overall circuit is designed and how it does what it does. He can give that description far better than I can. Now the other point as well is that he actually sells Eurorite kits of his designs, and the kits, they come with the same excellent instructions, full documentation and everything else. So because of that, I'm not going to give any of his diagrams or have you here. If you want those, I'll give the link to his video. Go and have a watch the video. I recommend you watch it anyway because you will get a really good understanding of how this circuit works. And if you do want to go down the Eurorite DIY kit route, then his video will have links to where you can buy his kits. Now, I don't do Eurorite, I do Project 12, and Project 12 doesn't follow Eurorite standard. It pretty much follows its own standard. There'll be more on that later when we come to do some demos of what this thing's capable of. So I haven't gone down the route of buying the Eurorite kit. I've put together my own strip board layout, and that strip board layout looks like this. So you can see, yeah, I said it was a fairly simple circuit. You've got a quad op amp there and a JFET transistor and very few other components. I was surprised at how amazingly simple the circuit was. So I built that as a strip board, and yeah, got it working. Sounded great. On that version, it uses an external input for the signal, which is the signal that is going to be sampled to provide CV output, and it uses an external trigger, which is generally something like a clock or an LFO square wave, which determines the rate at which those samples are taken. Now normally on sample and hold, or most commonly on sample and hold, is the signal input will be white noise because it has all frequencies, so you can sample all frequencies. And you generally use, as I said, an LFO to trigger the sampling. So I wanted to build all this into the same module. So I've done a second board which has a square wave LFO and a white noise generator. Now these are a couple of circuits that I've used before elsewhere in Project 12, but the circuit diagrams I knocked up look like this. So at the top there you've got the LFO, and then underneath it you've got the white noise generator, and again they're just based around a quad op amp, the TL074 quad op amp. So again, fairly simple, fairly straightforward. So I built a separate board for that, and my strip board layout for that looks like this. Again, fairly simple. Now I'll put links where you can find my strip board layouts and my circuit diagram on the Dropbox folder, like I normally do. So that will be down in the description. And when I put the circuit together and put it on the back of a panel, it looks like this. So you can see the two piggyback boards there, and if you look down the back of the panel, you can see there you've got the sockets, and you can see that there's a switch there. Now it's a double pole double throw switch, which allows me to switch between internal and external signal and trigger inputs. And the wiring of the switch is fairly straightforward, but that it looks like this. So this is just a quick diagram of how you can wire up the double pole double throw switch. Yeah, so that's it. Fairly simple, fairly straightforward, but what does it sound like? Well, we'll go over to Project 12, we'll have a quick look at what all the inputs and controls are, and then we'll have a listen to some of the kind of things that it can do. This is the sample and hold module. Quick run through the various inputs and controls. Starting at the top, SIG is the signal input, so this is the signal that is going to be sampled in order to generate a CV output, and CV output at the bottom there. The level controls the overall voltage level of the signal that's coming in, so it's a bit like a cutoff, if you like, which will determine what the maximum voltage that could be sampled will be. You'll hear more about that. I'll twiddle with it when we get a demo going. Trig is a trigger input, and the trigger input controls the rate at which the signal input is being sampled. That's normally a square wave like an LFO or a clock signal or whatever. We've got an external internal switch. It's switched to external at the moment, so at the moment these are the signals that are fed to the sample and hold circuit to generate the CV. If I flick it down to internal, it then disconnects these and connects the onboard white noise and LFO. The rate of that onboard LFO is controlled with this knob, and there's a LFO output there, so if I can take whatever's being fed into the signal and hold as the trigger signal, so that now becomes a trigger signal. These are redundant. I can then take a version of that out to sync with other things like VCAs or whatever, or envelopes. So you can use that as a kind of a clock signal. Of course, the white noise is one with that in the internal is patched straight into it goes through the level control, but it's just white noise. There's no other control, because white noise is all signal, all frequencies, just basically playing through. And the thing about white noise is if you start sampling white noise, you can get something that approximates to a true random sequence. Now, what I've got set up for this demo on the external won't provide a true random sequence, because the signal input I'm using is a triangle wave VCO. It's the triangle wave output on my origami module, and the trigger input is coming from my clock module, so that's just a square wave input, and the CV is going into a saw wave VCO, the output of which is going through the diode ladder filter, and the CV, the cutoff on the diode ladder filter, is being controlled by the same CV that's coming out of the sample and hold. I don't know whether all that makes sense, but let's have a listen to what we're going to get when I turn it on. So you can hear it's kind of a repeating sequence. That's because we're feeding it the triangle wave, which is a repeating signal. I can change the cutoff. You can hear we start to get more higher frequencies sampled. And of course, because I'm using the same CV for the filter, it opens the filter more. And I can control control the clock rate. I can control the rate at which things are being sampled. You can hear the triangle wave there. You've got a ladder going up and a ladder going down, so we're fairly closely in sync with the triangle wave. If I speed it up, it sounds vaguely random, but it will actually repeat the sequence because it's basically shifting phase between the triangle wave and the square wave that's doing the triggering. So it's not actually random. Right, so that's external signals going in there. I plug this in here and switch that up there and switch this to internal. You won't hear anything. Now, one of the reasons it's actually firing, one of the reasons you don't hear anything is that this is not all following Eurorack standard, so the voltages vary considerably between modules. If I turn things up, because the internal circuit on the LFO and the noise is producing a lower voltage output than what I was getting from the triangle wave and the clock generator. So I need to adjust things. So now I've got it's white noise that's producing the CV, and I can change the level there. It sounds less and less random because you've got less and less voltage to play with. And then the LFO rate. Just go around adjusting things, because basically you're playing with voltage levels, so you adjust controls to adjust voltages until you find something that is kind of doing what you want to do. And we're into the realms of spaceships and sci-fi now. Yeah. So, lots and lots of fun from sample and hold. Now you could just build the Moritz Klein sample and hold circuit, either from his kit, which would be fantastic, or do what I did and put it on your own strip board, and then just use external signals. Or you could go down the route that I went down and build onboard white noise and LFO, so that your sample and hold is a standalone random CV generator. And I've given you links to the various websites that you need. I've given you my circuit diagrams and stripboard layouts. There's links to those. So yeah, if you want to play around with sample and hold, and I can highly recommend it, then go on, have a go, build your own.